Can we calculate how fast the Earth moves around the sun? And the answer is yes, we can. What we're going to calculate is the tangential velocity. So for example, the tangential velocity would point like this at this point. But if Earth was right here, it would point in this direction. If Earth was right here, it would point in that direction. If Earth was right here, it would point this direction. I think you get the idea. Now the way to calculate this is using this equation right here. On top of the velocity equation, this is the circumference of a circle. So the distance of this circle is the top of this equation. The bottom of this equation is the period, and the period is how much time it takes to complete the circle. Notice that we have distance over time. So let's go ahead and see if using this equation and given this distance that we have from Earth to the sun, which is 94 times 10 to the 6th miles, how can we go about calculating the velocity? Well, in this case, what we're going to need to do is find a radius and a period, and we can just plug it into this equation. But notice we have this is our radius, because if Earth moves in a circle around the sun, this distance right here is going to be your radius of your circle. So we have our radius right here. The only thing we need now is a period. So how can we go about calculating the period? We know just from knowledge that the period is going to be 1 year, because it takes 1 year for the Earth to get around the sun. Or in that case, we could say it's 365 days. Now you might just think we can take our radius here and plug it in there, and then take our period here and plug it in there. But the answer is that we can't. Because if we did that, we would be calculating a velocity in miles per day. That's not really a speed unit that we're used to working with. So what we want to have is meters per second. So what I'm going to do is convert this number right here to meters, and then convert this number right here to seconds. So here I'm converting my miles to meters. Remember, we had 94 times 10 to the 6th miles, and something that you should know is there's 1.61 kilometers per mile, and there's also 1,000 meters per kilometer. Notice doing this, I can cancel the miles, I can cancel the kilometers, and I'm left with just meters. So what I can do is multiply all the top numbers across and multiply all the bottom numbers across, and then run the fraction by dividing the two. And that will give me this number right here. Now I'm also going to convert the days to seconds. Notice that I have the days on top which cancel with these days. I have the hour here which cancels with this hour, and the minutes which cancel with these minutes. Multiplying everything on top divided by the product of everything on bottom, I will get 3.2 times 10 to the 7th seconds. So this is what I get for meters, this is what I get for seconds, and then if we bring these back to our original problem, now we can plug this in for radius, and now we can plug this in for period. So I'm plugging these in on the top and on the bottom, and if you type that into your calculator exactly as you see it, you're going to get that the tangential velocity of Earth is approximately 29,649 meters per second. And of course, this is an approximation because we rounded quite a few numbers, but I bet you that if you Googled the speed that Earth's moving around the sun right now, it would be close to 30,000 meters per second, which is what we calculated here.